W90Y. I'm going to demonstrate how to use the Flex 6000 radio to determine isolation between antennas. What I have set up here is a Flex 6700 on the upper panadapter, panadapter A. I have set up on antenna 1 for the receiver a vertical antenna, which is in my backyard. It's a 40 meter half wave end-fed vertical over about 4,000 feet of wire. I'm using this antenna as my transmit antenna as well. And on panadapter B, I have set up on antenna 2 a dipole in the front yard. It's a 102-foot G5RV variant W5GI antenna, and I have it tuned to 40 meters using the tuner in the radio. So now what we're going to do is transmit on A. See, the transmitter is turned on, and receive on B, and measure both here in this field. We're going to look and see at the dB that's presented. This measures the dB of the S meter. So this is slice B, and you can see that I have a minus 95 noise right now, and I have about 100 minus 100 dB on panadapter A. So we're going to go ahead and send some. Now I'm set at 10 watts power, and we're going to go ahead and send some dashes and see what it looks like. So you can see in the upper panadapter the transmitted signal, and in the lower panadapter you can see the received signal on the dipole. So I'm transmitting on the vertical and receiving on the dipole. Down here you can see that the baseline is at about a minus 115 or so, 110. And when I go to transmit, the baseline drops to nearly minus 140 on the panadapter. This implies that that the ADC is disconnected from the antenna circuit, and the only thing I'm picking up is the leak through RF on the ADC. I can turn on full duplex, and if I turn on full duplex, you'll see that the panadapter does not drop when I transmit. You can see that it over at the about 10 kilohertz away, it remains at about minus 115. This indicates in full duplex that the ADC is not disconnected from antenna 2. So now we're going to look and see what the level is on the ADC with the antenna disconnected when I transmit. So you can see the peak is about minus 60 dBm. Minus 60 dBm. I'm transmitting at 10 watts. I'm now transmitting at about 80 watts. 80 watts. And you can see that it's raised up to about minus 50 in that ballpark dBm on the panadapter. Let the amplifier warm up here. I'm now going to transmit at about 1200 watts. That's 1228 watts right now, and I'm up to about minus 45, 42, something like that on the receiving panadapter with the antenna disconnected. This is a half duplex setup. So this is these two antennas are well within the spec. The Flex 6700 overloads at about plus 12, plus 13 dBm, and it has a automatic cutoff circuit at some level higher than that, something like plus 17 dBm or something like that for protection. So at minus 42, I'm well below any problem, even though I'm running 1200 watts on two antennas that are separated by 175 feet. I'm going to turn on full duplex and we'll see what that does. So at full duplex, you can see that I'm getting about 3.3 to 4 plus 3.3 to 4 dBm peak reading on this meter, on the S meter here. Let's look again. So that's about plus 3.7. This is running about 1200 watts between the two antennas, full duplex. So you can see even at full duplex with this setup running 1200 watts, I am well below where the about 10 dBs below where the receiver overloads, and about 15 dBs below where the receiver cutoff kicks in. So I can easily run two antennas separated by 170 feet and a kilowatt, and the radio's in absolutely no danger. 7.3 from W9OY.